Now we've learned that the graph of a quadratic function is a parabola, and we can find the vertex of the parabola using this to find the x-coordinate, and then plug it into the equation to get the y-coordinate of the vertex. That vertex is either the highest or lowest point on the curve. So it's a maximum point if the graph of the parabola is pointed down. That'll work. If the graph of the parabola is pointed down, then the vertex is the highest point on the graph. If the graph of the parabola is pointed up, then the vertex is the lowest point on the graph. All right, now the minimum value is the y, or the maximum value is the y, the k, the y. Where it occurs is the x value, the h. Let's give the coordinates of the extreme points of the graph of each function and the corresponding maximum and minimum values of the function. So, for this first function, my a is a negative 3, b is 4, and c is negative 1. So the vertex, the x-coordinate, is going to be at negative b over 2a. So negative 4 over 2 times negative 3 would be a positive 2/3. Now, to get the y-coordinate, I plug 2/3 into that equation. So that would be negative 3 times 4/9 plus 8/3 minus 3/3. So multiplying that would give me negative 4 over 3 plus 5 over 3. That's a 1 over 3. All right, so the coordinate of the extreme point for this first graph is 2/3, 1/3. And the corresponding max or min. First of all, because a is negative, the graph is opening down, so it's a maximum. The maximum is the y. All right, let's do the same thing for the second equation. My a is the coefficient of the x squared, that's a positive 1. B is a negative 5, and c is a positive 3. So negative b over 2a would be negative 5 over 2 times 1. That's 5/2. All right, let's plug that in to get the y-coordinate. P of 5/2 would be 5/2 squared minus 5 times 5/2 plus 3. So this would be 25/4 minus 25/2 plus 3 would be 12/4. Okay, so this would be negative 50/4 plus 25 would be negative 25/4 plus 12 would be negative 13/4. Okay, so my point is at 5/2 for the x, and the y is negative 13/4. Because the a is positive, I'm opening up, so the vertex is a minimum, so I would have a minimum value for the second one of negative 13/4. All right, let's find the equation of the quadratic function with a vertex at 1, negative 2, passing through the point 318. All right, so my vertex is at 1, negative 2. Now remember, the vertex form of a parabola is a times x minus h squared plus k. So this is the h, the 1, and the k is the negative 2. So I know my equation looks like p of x equals a times x minus 1 squared minus 2. Now I'm going to use this point to figure out the a value. I have to get back 18 when I plug in 3 for the x. So I'd have 18 equals a times, that would be 2 squared, Add this 2 to the other side. And I get 20 is equal to a times, that would be a 4. A is 5. So that means, plug it back in here, that means my equation is P of x equals 5 times x minus 1 squared minus 2. And there's the equation of that quadratic.